Hello everyone. This is the second part of the topic method of separation of variables for wave equation. In the last lecture we were discussing the method of separation of variables for wave equation. So we considered the wave equation along with the boundary conditions u of x ux of 0 t equal to ux of lt equal 0 and the initial conditions are given by f and g. Okay. So when we find the solution, we obtain that the solution of this differential equation utt minus c square uxx equals 0 along with the boundary condition we obtained the solution as this u of x t equal to a naught plus b naught t by 2 plus summation n from 1 to infinity a n cos n pi ct by l plus b n sin n pi ct by l into cos n pi x by l. Okay, so number it as 11. So now our aim is to find the Fourier coefficients a n and b n for n equal to 0, 1, 2, 3, etc. So for that we need to apply the initial conditions which are u x0 equal to f of x and ut x0 equal to g of x. So we need to apply these two initial conditions. Okay. For that, first of all, we are assuming that the initial data f of x and g of x can be expanded into the generalized Fourier series uh, with respect to the uh, eigenfunctions cos n pi x by l. Okay, that means we are assuming that f of x and g of x can be expressed as, that is, f of x can be expressed as a naught by 2 plus summation n from 1 to infinity a n cos n pi x by l. That is, we are assuming that this f can be expressed as a generalized Fourier series with respect to the eigenfunction cos n pi x by l. Similarly, g g of x is equal to a naught tilde by 2 plus summation n from 1 to infinity a n tilde cos n by x by l. Okay, so we are assuming this. Okay, now our aim is to find our aim is to find the Fourier coefficients a naught, b naught, a n and b n for n equal to 1 to 3, etc. So here first we are going to find the coefficients a naught, an and a naught tilde n tilde. Okay, so for that first we are multiplying this equation number 12, that is the expansion of f of x by the eigenfunction cos m pi x by l. Okay, and integrating over the interval 0 to l, then we get integrating we are integrating from 0 to l by multiplying cos m pi x by l. So we have integral 0 to l f of x into cos m pi x by l dx is equal to a naught by 2 is a constant, so a naught by 2 into integral 0 to l cos m pi x by l dx plus summation n from 1 to infinity a n into integral 0 to l cos m pi, we are multiplying this, so cos m pi x by l into cos n pi x by l dx. Okay, so our aim is to find a naught and a n. Okay, for n equal to 1 2 3 etc. So we are just applying this formula. We already know that integral from 0 to l cos m pi x by l into cos n pi x by l dx is equal to 0 when m is not equal to n, and uh, it is equal to l by 2 if m is equal to n which is not equal to 0, and it is if m equal to n which is equal to 0, we have the value of this integral is l, that is m equal to n equal to 0 means it is nothing but cos 0 into cos 0, that is integral 0 to l dx, that is the value will be x from 0 to l, that is l. Okay, directly we get this, and this is m equal to n, that is when m equal to n we have cos square n pi x by l dx, it will be the value will be n l by 2. So we can apply this. So first of all, to get a naught, we are just replacing m by 0. So when m equal to 0, we have this integral 0 to l f of x into cos 0 which is 1, that's dx is equal to a naught by 2 into integral 0 to l cos 0 dx, that is integral 0 to 1 l 1 dx. Okay, this is when m equal to 0. Okay, so we have in that case it will be 0. Okay, So because here we are taking only n from 0 to 1 to infinity. So if you are taking m equal to 0 and it will be m is not equal to n, so that in that case it will be 0. Okay, the value of this integral will be 0. So we'll get if you are taking m equal to 0, we'll get a naught by 2 into integral 0 to L dx. 1 into dx is nothing but integral 0 to L f of x into dx. Okay, so from this we'll get a naught by 2, and this a naught by 2, this integral is nothing but the value of this integral is L, already we obtained from this, or we can directly integrate this. So this is equal to L equal to integral 0 to L f of x dx. So from that we get a naught is equal to 2 by L into integral 0 to L f of x dx. So this will be a naught. Okay, now to obtain an, uh, from this we can write if here the variation of n is 1 to infinity. So this integral is non-zero only when m is equal to n, right? So that means n is equal to m. So in that case we will get uh, a m into integral 0 to L cos m pi x by L cos m pi x by L, that is cos square m pi x by L dx. Okay, so we'll get a m into this integral 0 to L cos square m pi x by L dx is equal to integral 0 to L f of x into cos m pi x by L dx. Okay, so in that case it will be 0 because we are taking only the values value n equal to m only. Okay, we are not taking m equal to 0, n equal to 0, right? So this will be 0. So from this we get am equal to L by 2 into integral 0 to L, because we have this is when m equal to n, that is m equal to n, we have the value of this integral is equal to L by 2, that is cos square m pi x by L dx. Integral of this is nothing but L by 2. So am into L by 2, which is equal to integral 0 to L f of x into cos m pi x by L into dx. So from this we get am is nothing but 2 by L into integral 0 to L f of x into cos m pi x by L dx. So we'll get this as am for m is equal to 1 2 3 etc., and a naught is equal to this. Okay, similarly we'll get here yeah, just if you multiply this second equation, that is the equation number 13, with cos m pi x by L and integrating over 0 to L, we will get in a similar way of this we'll get a naught tilde and a n tilde as this. Okay, we will get a naught tilde will be 2 by L into integral 0 to L g of x dx, and am tilde will be 2 by L into integral 0 to L g of x cos m pi x by L dx. Okay, the only difference is f of x is changed to g of x. Okay, so this will be the Fourier coefficients of that f and g. Okay, a naught tilde and am tilde are the Fourier coefficients of g, and that of f are a naught and am. Okay, so now we can apply the initial condition. The first initial condition is u of x0 equal to f of x. So when we apply this initial condition, that is when t equals 0, we have u equal to f of x. That means we'll get a naught by 2 plus we have u of xt is nothing but this. Our solution is this. So when t equals 0, we have a naught by 2 plus summation n from 1 to infinity. When t equals 0, we have sine 0 is 0 and cos 0 is 1. So here a n into cos n pi x by L. Okay, so a naught by 2 plus a n into cos n pi x by L will be u of x is 0. So when we apply that condition, that is u of x is 0 equal to f of x, implies a naught by 2 plus summation n from 1 to infinity a n cos n pi x by L equal to f of x, where we have obtained that f of x is equal to a naught by 2 plus we are assumed that f of x can be expressed as this Fourier series a naught by 2 plus summation n from 1 to infinity a n cos n pi x by L. Okay, so we can equating these coefficients, we will get a naught is equal to a naught, that is capital A naught is equal to small a naught, and capital A n is equal to small a n, because the generalized Fourier coefficients are uniquely determined. Okay, so we have a n is equal to a n for n is equal to 0 1 2 3 etc. Okay, n equals 0 1 2 3 etc. That means we have the Fourier coefficients or our the constants of our solution u of xt is a naught is equal to 2 by L. That is, this is a small a naught, which is 2 by L into integral 0 to L f of x dx. We are obtained as this. A naught is equal to 2 by L into integral 0 to L f of x dx, and an is equal to this 2 by L into integral 0 to L f of x into cos n pi x by L dx. So we have the our recurred constants are given by a naught is equal to 2 by L into integral 0 to L f of x dx, and an is given by 2 by L into integral 0 to L f of x into cos n pi x by L dx, which is a small a, right? Now our aim is to find bn, okay, that is b naught, b1, b2, etc. For that we can apply the second initial condition, which is ut of 0t equal to ut of x0 equal to g of x. Okay, so for that, first we need to differentiate our solution u of xt with respect to t. That is, ut xt is nothing but b naught by 2. We are going to differentiate our solution with respect to t. So our solution was this. So differentiating our solution with respect to t, we have ut is nothing but b naught by 2 plus summation n from 1 to infinity. Differentiating this with respect to t, we have n into n pi c by L into minus sine of n pi ct by L plus bn into n pi c by L into minus into cos of n pi ct by L into cos n pi x by L. That will be bn ut, right? So which is this utxt is equal to b naught by 2 plus summation n from 1 to infinity minus an n pi c by L into sin n pi ct by L plus bn into n pi c by L into cos n pi ct by L into cos n pi x by L. So we are differentiating with respect to t here. Now we can apply the second initial condition, which is ut x0 equal to g of x. So this is nothing but when t equals 0, we have this term equal to 0, and this term will be 1. So bn into n pi c L by L will be here, cos n pi x by L. So we have b naught by 2 when t equals 0, we have b naught by 2 plus summation n from 1 to infinity bn n pi c by L into cos n pi x by L, right? Cos n pi ct by L will be 1 when t equals 0. Okay, so we are given that this is equal to g of x. So we could and we assumed that g of x is equal to a naught by 2, that is a naught tilde by 2 plus summation n from 1 to infinity an tilde cos n pi x by L. Okay, so uh, from this we get b naught by 2 will be equal to a naught tilde divided by 2, that is b naught is equal to a naught tilde. Okay, comparing the coefficients, that is, and bn will be equal to n tilde L divided by n pi c, because bn into n pi c by L is equal to n tilde, that is bn into n pi c by L is equal to n tilde. So from this we get bn is equal to n L divided by n pi c. Okay, so we have bn is equal to this. Okay, therefore our b naught is nothing but a naught tilde, which we obtained before us, 2 by L into integral 0 to L g of x dx, and bn is nothing but an tilde L divided by n pi c, that is L by n pi c into an tilde, where an tilde is this. Okay, this is an tilde. So we have bn is nothing but 2 by n pi c into integral 0 to L g of x into cos n pi x by L dx. So we have obtained the coefficients b naught, bn, and a naught and a. Okay, so it is because a naught equal to this and an tilde equal to this. So we just replace this. Okay, here a naught tilde and an tilde will be this. Okay, so we have obtained a naught, an, b naught, and bn. So the solution of this problem is, okay, so if you have a problem like this, utt minus c square into uxx equals 0 along with these boundary conditions and initial conditions. Okay, we can directly write the solution as uh, uh, u of x t equal to a naught plus b naught t divided by 2 plus summation n from 1 to infinity a n cos n pi c t by l plus b n sin n pi c t by l into cos n pi x by l, where a naught, b naught, a n and b n can be obtained by using this formula. Clear? So once we obtained this the coefficients a n and b n, we can write the solution. Okay, this. So this solution is obtained by using this, by solving this partial differential equation along with these boundary conditions. Okay, so if we solve this boundary condition, this partial differential equation along with this boundary condition, then we will get this solution. And once we apply this initial condition, then only we get a naught, a n and b naught and b n. So if we know this the initial conditions g f of x and g of x, we can directly use this formula to find a naught, a n, b naught and b n. Okay, or otherwise we can directly use these conditions from here to obtain the corresponding coefficients a naught, b naught, a n and b n. Okay, uh, without finding this integral, we can just using these initial conditions we can find the coefficients. Okay, so we can discuss a problem. Solve the problem utt minus 4uxx equals 0 for 0 less than x less than 1 and t greater than 0, ux 0 t equal to ux 1 t equals 0 and t greater than or equal to 0, for t greater than or equal to 0. U of x is 0 equal to f of x, which is cos square pi x. That is the this is the initial condition, first initial condition, and the second initial condition is ut x is 0 equal to g of x, which is sin square pi x into cos pi x for 0 less than or equal to x less than or equal to 1. So we have a wave equation utt minus 4 uxx is equal to 0 along with the boundary condition and two boundary conditions and two initial conditions. Okay, so from this differential equation we can say that c square equal to 4, so c equal to 2. Okay, and l is equal to, that is boundary is 0 to l, that is l is equal to 1 here. Okay, so we will get the solution as, we can write this differential equation with this conditions. We'll get the solution as u of xt is equal to a naught plus b naught t divided by 2 plus summation n from 1 to infinity a n cos n 2n pi t plus bn sin 2n pi t into cos n pi x, because l equal to 1 here and c equal to 2. We have the solution as this is the solution, and here we have l equal to 1 and c equal to 2, so we have cos n pi 2t, that is 2n pi t, this is 2n pi t, and bn into sin 2n pi t into cos n pi x by l is 1, so into cos n pi x, that will be our solution. Okay, so now our aim is to find the coefficients a naught, b naught, a n and b n for this to obtain the solution. Okay, for that we are just applying this initial conditions. So first initial condition is u of x 0 equal to cos square pi x, so applying that condition we get u of x is 0 equal to cos square pi x, which is nothing but when t equal to 0 we have u equal to cos square pi x, that is when t equals 0 we have this is a naught by 2 plus summation n 1 to infinity, t equals 0 means this is 0 and cos 2n pi t is 1, that is a n into cos n pi x, so a n into cos n pi x equal to cos square pi x. So we can expanding this, we get, our aim is to find the coefficients a n, a naught, a1, a2, etc. So this is nothing but a naught by 2 plus summation n from 1 to infinity. So expanding this series, we'll get a1 into cos pi x plus a2 into cos 2 pi x plus a3 into cos 3 pi x plus etc. equal to cos square pi x can be written as 1 plus cos 2 pi x divided by 2. So equating the coefficients of on either side, we'll get a naught by 2 is equal to 1 by 2. That is constant term is a naught by 2 here, and here is 1 by 2. So a naught is equal to 1. And a1 is the coefficient of cos pi x, which is 0 here. That is the coefficient of that is, there is no term in right hand of cos pi x. So a1 will be 0 a2 equal to coefficient of cos 2 pi x, which is 1 by 2 from here. So a2 equal to 1 by 2 is the coefficient of cos 3 pi x, which is also 0. a4 is also 0, etc. All the other constants are zeros. Okay, so we have the only non-zero terms or non-zero coefficients will be a0 equal to 1 and a2 equal to 1 by 2. a0 equal to 1 and a2 equal to 1 by 2 here. Clear? The only non-zero coefficients are these. Okay, now next our aim is to find bn. For that we can apply the second boundary condition, second initial condition, which is utx0 equal to g of x, which is sine square pi x into cos pi x. Okay, so to apply this initial condition we have to find the first derivative of that is the u with respect to t, first derivative of u with respect to t, that is finding the partial derivative of u with respect to t. We have ut is equal to b naught by 2 plus in differentiating this with respect to t, we will get minus 2n into an, 2n pi into an into sine 2n pi t plus bn into 2n pi into cos bn pi t, 2n pi t into cos n pi x. Okay, so here we can apply the second boundary condition, initial condition, which is utx0 equal to sine square pi x into cos pi x. So when t equals 0, we have b naught by 2 plus t equals 0 means this term will be 0 and this term will be 2n pi into bn into 1, that is 2n pi into bn into cos yeah, n pi x, yeah, here is n pi x, so cos n pi x, which is equal to sine square pi x into cos pi x. So this is equal to 1 minus cos square pi x into cos pi x. We can write sine square pi x as cos square pi 1 minus cos square pi x. So this is nothing, 1 into cos pi x is cos pi x minus cos cube pi x. So we know the expansion of cos cube theta is cos 3 theta plus 3 cos theta divided by 4. So we can replace cos cube pi x as cos 3 pi x plus 3 cos pi x divided by 4. Okay, so we'll get cos pi x into 1 minus 3 by 4, that is 4 minus 3 by 4, that is 1 by 4 into cos pi x minus 1 by 4 into cos 3 pi x. So this is nothing but, so we have this series is equal to this. Okay, so comparing the coefficients, we have b naught by 2 equal to 0. There is no constant term in the right hand side, so b naught by 2 equals 0. So we have the first coefficient b naught is 0 here. Okay, and when we expanding this, we get here also we have we can expand this. So expanding this, we'll get b naught by 2 plus when n equal to 1, we have uh, b1 into 2 pi, that is 2 pi b1 into cos pi x plus when n equal to 2, we have 2 into 2, that is 4 pi b2 cos 2 pi x plus etc. And the third term is when n equal to 3, that is 6 pi b3 cos 3 pi x plus etc. equal to this. So equal to 0. Now 2 pi b1, that is 2 pi b1 is equal to 1 by 4, coefficient of cos pi x. So from this we get b1 is equal to 1 8 pi. Okay, this is b1. And b2 is the coefficient of that is 4 pi b2 is the coefficient of cos 2 pi x, which is 0 because here there is no term for of cos 2 pi x, so b2 equal to 0. Okay, and b3, what about b3? So to find b3, we have 6 pi b3 into cos 3 pi x is equal to minus 1 by 4. So from that we'll get b3 equal to minus 1 by 24 pi, and b4 b5 b6 etc. equal to 0. So we have only two non-zero values for bn, that is b1 and b3. So applying these values for an and bn in the solution 1, we get our required solution. Our solution was u of x t equal to a naught plus b naught t divided by 2 plus etc. So replacing these values here, we have obtained only the values, non-zero values are for a naught equal to 1 and a2 equal to 1 by 2. We have the values a naught equal to 1, a2 equal to 1 by 2. Also b not equal to 0, so b1 is equal to 1 by 8 pi, b3 equal to minus 1 by 24 pi. All the other coefficients are zeros. So a naught is 1 and b naught is 0, so 1 by 2 here, plus when n equal to 1 we have a1 is 0 and b1 is 1 by 8 pi. So a1 is 0 and b1 is 1 by 8 pi means 1 by 8 pi into sine 2 pi t into cos pi x, right, when n equal to 1. So 1 by 8 pi into sine 2 pi t into cos pi x, plus what about n equal to 2? When n equal to 2 we have a2 and b2, but a2 equal to 1 by 2 and b2 is 0, so this term will be 0 in that case. So a2 equal to 1 by 2, that is 1 by 2 into cos 4 pi t when n equal to 2, cos 4 pi t into cos 2 pi x, plus when n equal to 3 we have only b3 which is non-zero and a3 is 0, so b3 equal to minus 1 by 24 pi. Since a3 equals 0 we don't have this uh, term with the a3, and bn is minus 1 by 24 pi into sine 2n pi t where n equal to 3, that is 2 6 sine 6 pi t into cos 3 pi x, okay, plus 0 0 0 etc., because the all the other values for an are 0, n and bn are zeros, okay. So we have the required solution is u of xt is equal to 1 by 2 plus 1 by 8 pi into sine 2 pi t cos pi x plus 1 by 2 into cos 4 pi t cos 2 pi x minus 1 by 24 pi into sine 6 pi t into cos 3 pi x, okay. So thanks for watching.